Space Watchers, and welcome back to our weekly nugget, where we analyze the space news of the week. Today we want to discuss about the upcoming COP29, which is going to start next Monday in Baku, Azerbaijan. How do we shift to a greener energy system, and what can space do to support this transition? There are several areas in which space can support a greener energy transition, from power grid synchronization to seismic surveying to identification of optimal sites for the production of renewable energy. But also, space can support what I call optimization of the resources. So, for example, thermal imagery to identify heat losses, or maybe traffic and route planning to save energy. But the one that I want to discuss with you today is the one that goes a bit more in the land of science fiction. Those space-based new solutions, the solution that can actually provide an alternative source of energy. I understand that these are long-term ideas and they have very high margin of risk, but I think it's still worth exploring, even just to dream a little. So let's see some of them. One is space-based geo-engineering, a method to alleviate the effects of climate change by reducing the amount of sunlight that hits the Earth. So we actually had an article about this week, check it out. This approach consists of the deployment of objects in space that can block or reflect sunlight away from the planet. Objects such as sunshades, reflectors, and mirrors. And this is an example from ASRI. This is the Cool Earth project, and just check out the video on the website. It's very nice. The second option is something that we discuss in SpaceWatch.Global often, is space-based solar panels, which are actual solar panels in orbit, able to collect sunlight 24 hours a day with no interference from the atmosphere. ESA has an experimental mission on this. It's called Solaris, and this image actually comes from them. And last but not least, this is in order of impossibility, in my opinion, there is harvesting a new source of energy from the moon, in this case, helium-free. Unlike Earth, which is protected by its magnetic field, the moon has been bombarded with a large quantity of helium-3 by the solar wind, and it is thought that the isotope could actually provide safer nuclear energy in a fusion reactor, since it's not radioactive. Now, it's important to point out that helium-3 quantities on the moon vary tremendously from paper to paper, from method to method. The latest samples that we have analyzed on Earth of helium-3 comes from the Apollo missions. So the samples analyzed in the 70s. A paper from 2013 calculated that we need 2 kilometers squares of moon regolith at 3 meters depth to actually extract 100 kilos of helium-3, which then could power a city like Dallas or Adelaide for 1 year. So this is an interesting premises, but we don't have the technology yet to power helium-3 fusion. So we might have the raw material, but we don't know how to use it. So what's my conclusion? My conclusion is that space-based energy solutions are long-term ideas that require some important investments. As usual, every idea is worth exploring, but maybe given the urgency of the issue, we should also find alternative short-term solutions to cope with the problem. I leave you with one observation. The G20 as a whole is responsible for approximately 3/4 of the global warming. The United States of America is responsible for the largest share of these emissions, followed by the European Union and China. And like many other things in life, contribution to climate change are unfortunately. Thank you very much, and Space Watch out.